One of the things we're going to want to do is come up with some broad classification of chemical reactions. It enables us to simplify the recognition of types of reactions. So one of the most easily recognized reactions is this. It's a combustion reaction. The way that we recognize these combustion reactions is that over here on the reactant side, we have O2. The presence of O2 as a reactant automatically classifies a reaction, whatever a reactant is, as a combustion reaction. Now, we may have some other ways of classifying the reactions, but a broad category for this type of reaction with O2 as a reactant is a combustion reaction. Then we have combination reactions. In combination reactions, we have multiple reactants. So in this case, we've got two reactants, but I could have some other reactant here. But the bottom line is all the reactants, however many reactants you have, combine, hence the word combination, to form one product. So that's how we recognize combination reactions, is multiple reactants and a single product. And then we have decomposition reactions. And decompositions are easy to recognize. You have one reactant, and you have multiple products. There could be another product out here, even another product, but the way you recognize a decomposition reaction is that a reactant decomposes into multiple products. So, combustion reactions we recognize because they have O2 as a reactant. We could have different products over here from a combustion reaction. A combination reaction we recognize we have multiple reactants, but we only have one product. If you see one product on the product side, multiple reactants, you know you have a combination reaction. And then a decomposition reaction really just goes the other way. We have one reactant and multiple products. So be able to recognize the different types of broad categories of reactions. So if I were to look at this particular reaction, this is ammonium chloride. And by the way, ammonium chloride is an ionic compound. This is something you have to watch out for. Even though there are no metals over here, remember the ammonium cation is a polyatomic cation. So just think of this as an ion, a cation, and then chloride ion has a negative charge, and they're attracted to each other by this positive negative charge into a crystal structure. So this is an ionic compound, and it is one reactant that's going to decompose into multiple products. So this is a decomposition reaction. Okay, pretty simple. Hopefully that wasn't too confusing for you. Combustion of hydrocarbons and carbon-hydrogen-oxygen compounds. Now, the first thing you want to recognize in this broad category of reaction is that it is a combustion reaction. And if it's a combustion reaction, you know that O2 is going to be one of your reactants. Now, I've mentioned this before. This is a compound composed of carbon and hydrogen. It is a hydrocarbon. Okay? We call this a hydrocarbon. This is actually methane, and methane is the simplest hydrocarbon. It's just carbon and 4 hydrogens. It's combined with O2, so you know that it's a combustion reaction. And whenever you have pure combustion, that is no side products, you have complete combustion of a hydrocarbon, you get 2 products, carbon dioxide, a molecular compound, and water, another molecular compound. So hydrocarbon combustion reactions, as long as it's pure combustion, you get two products, carbon dioxide and water. And the same thing is going to be true for carbon, hydrogen, and oxygen compounds in combustion reactions. They produce carbon dioxide and water. So here's glucose. You are burning this essentially in the process we know of as metabolism. Metabolism, you're combining glucose with oxygen and you're doing this combustion reaction. You're producing carbon dioxide, water, and your other product is a lot of energy. And you're using that energy to do all kinds of things, to do metabolic processes. And there's a lot of waste energy that comes off as heat. So you are, if you're running a normal temperature, you're somewhere in the neighborhood of 37 degrees Celsius. But in any case, that is a carbon, hydrogen, oxygen reaction. That is a combustion reaction. You produce two products, carbon dioxide and water, just like hydrocarbon combustion, which also produces carbon dioxide and water. This is something that I would keep track of. I would remember this. And here we have the good old sun. And the sun is a nuclear factory fusing hydrogen into helium. And ultimately, toward the end of its life, as it becomes a red giant, it will make elements, I suppose, up to around oxygen. That's about, our sun's not that large, so that is, I understand, about the heaviest element it can make. So all the iron and cobalt and nickel and gold and lead, all the heavier elements that we have on Earth came from supernova explosions from many, many billions of years ago that were incorporated into the synthesis of our solar system out of all of that nuclear debris. So in a sense, as Carl Sagan and Neil deGrasse Tyson says, we are made of star stuff. In another way, you could say we're made of nuclear waste.